we should be going live. I think it tells me I am live and I want to verify. Yes, good. So this is a 5-volt power supply and perhaps something else out of a wind turbine. It supposedly, according to the technician who gave it to me, just doesn't have enough power to actually work properly. And they really need to get this going, because every minute this is offline is costing them money. So this thing is relatively simple. It's got what seems to be SMP 4AP6, some kind of diode, probably some kind of transistor on the other side. No, that's another diode, that which seems to have been replaced at some point. And we have a board with a mystery IC there, a couple of big caps, transformer, which is a bit odd. So this is primary side transformer coupled and secondary side switching, probably. So a bit of an oddball design, and we really have a bunch of stuff on this tiny PCB. So what this does when we turn it on is it will turn on the, where's the front panel? There we go. It'll turn on the 5-volt DC LED as if everything's fine. It will not light the area LED, but it will just not give out proper power to the device which is being powered. Since this is switch mode, we have these really rather shoddy Philips caps there. These are prime suspects. We also have a bunch of caps here, also prime suspects, since it does seem to be putting out some kind of power. I am suspecting something relatively simple. It's a small box, it's got a big transformer. These always get a bit toasty, so it's going to have seen rather warm operating conditions, I would imagine. But for starters, I want to get this board off, just to have a peek at what we have underneath. And we have the output going through this big multi-plug, so I'm suspecting this thing does more than just provide power, since we have a couple of fat leads there which are probably power, red and black there. So this thing's probably got some brains to it, if it's just feedback or if it's some kind of control logic. I don't know what's this thing actually called. It's just labelled internal power. Someone in chat says that's quite a transformer for a switching power supply. This is a primary side transformer coupled supply, so this is just a mains transformer. It's secondary side switching. So instead of having a linear regulator after a transformer, it's just got a switching regulator instead. So other possible failure modes, we have these MILF resistors. These are notorious for getting bad solder joints if they run warm, so we need to check that out. Yeah, let's just start by getting this small top board out to have a look at what we actually have there. I just heard a noise from over there. I have my wide-angle camera very precariously placed. I'm hoping it's not going to go flying, because that would be a very expensive thing to happen. Probably not as expensive as this thing though. I'm really hoping we're going to be able to get this thing up and running today, that it's not going to have some weird oddball IC that no one's going to get their hands on. We do have, I can show you guys, something which looks a bit horrifying, and IC I have not heard about before. This is an SG3524. SG3524. And where's my microscope camera mirrored? Give me a sec. I think it does that by default for some really strange reason. There we go. SG3524. That could be an XL3524. I might actually if this is the same as the XL3524, I might actually have some of these. So that would be excellent. I don't know where they are though. What's up with that diode? Is this okay? What is this? What is that? What is going on here? That seems to be just how the plastic's manufactured. Doesn't seem this device has a hole in it. It looks more like a jumper than anything else as well. Doesn't seem to be any semiconductor. I'd wager this is just a ferrite or a pure jumper. And if we measure it, we're going to have continuity across it. I want to verify now that we actually found something looking funny. And yes, that is a straight short, which I would suspect it to be. It's not going to be a diode. This is just a jumper or a ferrite. So no problems there. That's the wrong camera. There we go. I need to get this chat out of the way of a microscope. Can I rearrange my things? I can't rearrange my things. Someone in chat says this is the worst thing of both worlds, the inefficiency of a transformer and the high noise from the switcher. In a way, yes, but these tend to be quite reliable, and they provide better mains isolation than a pure switch mode device, since you have a big honking transformer to actually isolate you from the mains. I don't mind these usually. I need a 5.5. I have misplaced my 5.5. Back in a sec, I need to fire that thing. I have no idea where my 5.5 has gone. Oh well. We'll have to make do. Maybe this will cut it. Nope. Maybe this. Nope. Perhaps some American size. Yeah, that's going to work. That is going to work. Someone is asking, why is rewind disabled? I don't know. I must have changed that setting at some point, or it's just disabled by default. I don't know how to turn it on. Sorry. I am not good with computer. Okay, these are just risers. We have a screw there going through the switching choke. That's probably going to be what allows us to actually take that apart. Yeah, I can feel the board moving. There we go. So we do have a bunch of capacitors on this board. This poor guy seems to be a bit discoloured on its label there. If it's just a single layer board as well, we could have soldering issues on that. I thought it was all double layer, but seems not. I haven't even checked this with the main board double layer. Yeah, this board is a double layer plate through, so I would not expect soldering issues on the main board. But on this one, it certainly is a possibility. And I want to take a couple of pictures just to have a backup of it. There we go, and we have another SG3524 down in there. That ought to cover most of it. SD cards are cheap, destroying industrial power supplies by putting stuff back in the wrong way. That's expensive. So, yeah, since this is a single layer board, let's just have a look under a microscope to see if we have any soldering issues. I don't think we will. This seems to be a very high quality device. It's about 25 years old, so it's been a bit of leaded solder. Also it's industrial, so yeah. Also it's not a, what's the brand of those bad wind turbines? It's not an Enercon. Enercon wind turbines tend to have lots of solder faults, but this is a Vestas brand. That's all hand soldered and beautiful. We have a solder ball there. A solder ball. It's not an issue, but we need to be rid of that. Unnecessary. I'm not seeing any failed solder joints anywhere on this board. All the through-hole stuff is done by hand, which is usually a very good sign. Well, hello, what's that? What's up with you? What's up with you? I don't think that's an actual solder crack, but it is a tendency. Let's get a blade to that to see what's actually going on. It is a tendency to crack, yes. It's not just an artifact. So this is a beginning solder joint crack. It has not failed yet, but it will. So that alone, it's on a capacitor though, which so we're probably going to be replacing those anyway. So let's not get too fussed about it. Someone in chat says, "Hello, Sir Cossack. I am not a knight, but hello." So now we have at least confirmed that we do have some solder joint failures in this thing, or at least tendencies. So we need to keep a keen eye on that kind of thing. Those are a bit ugly, but they're fine. A bit ugly as well, but probably fine. Yeah, that seems to be on there. I don't think, unless we have an IC failure on this board, I don't think this board is going to be our culprit, but we do have our SG3524 there, which I think might perhaps be an issue. But let's desolder one of these capacitors and measure its ESR and capacitance. They are brand name caps, but brand name caps do fail after a long enough time. $220.25. I sadly do not have a display capture setup for my workbench computer, so you'll just have to take my word for any values I report. Someone says SG3524 and TL494 variant PWM ICs are very common, but where's the main switching component? They are the main switching components, since we have a primary side mains transformer for taking the primary down and providing isolation. So we don't have a main switching converter because that's our transformer. We're fine with just PWM control ICs in this application. Where is my software? Where is my software? There's my software. Maybe you can kind of see that if I make it just the right size. Server leads. Oh, I have a touchscreen. Ah, that's amazing. Touchscreen. Haha. Beautiful. Let's just if you really want to, you can kind of make out the meter there. So here's our 220 microfarad Nichicon PL capacitors, and let's see what we have. That looks absolutely fine, I would wager. 150 milliohms to 30 microfarads, but I do want to check the datasheet for Nichicon PL to make sure that's actually okay. Nichicon PL. It's an old series, it's turned into PM. Oh. PL equals PM, but I'd rather have a datasheet for PL. Oh, fuck's sake, give me a datasheet for PL. It's not going to happen, we're going to have to go with Nichicon PM. Hopefully they are completely directly replacing. And Nichicon server is the slowest thing in the entire world. I'm suspecting that 150 milliohms is going to be absolutely fine for the 220 microfarad variant. Standard rating 25 volts, 220. Impedance 110 milliohms is fine, so yeah, that capacitor is not an issue. Those capacitors are not our problem. So I'm just going to put that back for the time being. Someone's asking, what outputs does that power supply give? It's 5 volts and something. All I know for sure is 5 volts, but we have this big ribbon cable-y thing going as well, and I don't know what that's for. It could be doing some kind of a diagnostic thingy. It's got an LM311, another weird IC down there. Yeah. I'm not liking this. An LM311, I think that's a comparator, and a 7705 AC. What is a 7705 AC? Something TI supply voltage. Power on reset generator. RECDSTRM. A power on reset generator. I'm quite sure the LM311 is a comparator. Differential comparators, yeah. So nothing going on there, nothing too specific. I might have some of those in stock. Let's measure more capacitors actually, since this thing does have a crazy amount of hours on it. So we have 2 smaller caps on this board. $180 milliamps, 340 microfarads there. Something similar there. I think those guys are in parallel. Yes, they are. They're across the 5 volt rail. I can't quite see the ratings there. They're 100 microfarads, 16 volts. So I would wager that's absolutely fine. I do not think those capacitors are bad. We have another 116 over here. And that one's in parallel with the 2 others. So 3 of those together giving us a bit over 300 microfarads. So that's pretty good, I would wager. And let's just measure the other 220s as well. So this is a bunch of them in parallel. We have 970 microfarads and 69 milliohms. This one's probably in parallel as well. Yeah. Probably this one as well. Well, it's going to be all 4 of them in parallel since we're at about 1000 microfarads. Those are all fine. I want to check the big caps as well. These are 2200 microfarads something. Probably over the highest voltage we have output for. 58 milliohms, 4000 microfarads. Those 2 are going to be in parallel. That's going to be absolutely fine. The ugly blue Philips capacitors are not a problem. They often fail in switch mode applications, but they are just the decoupling caps for for the 50 Hz mains transformer, and they tend to last quite a while as long as they're not overloaded. So that's not an issue. We do have some very ugly hack going on over there though. Let's have a look. So that's a very big capacitor jumping over. Is that even a capacitor? It could be a ferrite. That actually looks a bit iffy, to be perfectly honest with you. The auto exposure on the camera is not letting you get a very clear view. However, there is apparent cracking along there. Yeah, you're not going to see shit. Sorry. Well, that actually does look quite bad. We need to... Oh, there you go. Now you can see it. Someone asks, is that even touching either of the pads? No, they've just gobbed on a bunch of solder until it's stuck. It does not seem to be cracked to the point of failure though, but that is very, very ugly. Very ugly. Wow. Is that supposed to be... it is very dark, so I would wager that's a ferrite of some sort. But I really don't like the look of that. Jeez. We have a good continuity across there. This is measuring all kinds of weird. All kinds of weird. But I'm not sure what this even is, what type of component it would be. It is not a short. Is that some kind of capacitor? That would be very strange. It's measuring 130 nano. So that could be... that could be a capacitor. Wow, that's ugly though. Let's just take that off and make sure it's not just gobbed down onto the track it's trying to cross, trying and failing to cross. Fume extractor. That does not seem to have shorted to the track below. But I'm just going to clean that up and put some Kapton tape underneath it just to improve quality a bit. Q-tips. And booze. Always with a booze. Someone in chat is saying, little guy wants to be a 1206 when he grows up. Indeed, that seems to be the case. Alas, he's 25 now, and he never got out of a starting booth. Or who knows, maybe he started out as an 0402. That's decent. Let's just get some Kapton tape on there, so we're not just relying on the solder resist for preventing that thing shorting down to whatever's underneath. Oh, that actually doesn't matter because the pad is going to the thing it's jumping. Why have they done it like that? That's stupid. We can just do this better. We can do this so much better. Come on. I'm disappointed. Disappointed! So we're just gonna completely ignore that piece of Kapton tape I just wasted and scratch off a bit of pad. Yeah, that's gonna work just fine. Someone said measure rotative circuit too. Yeah, we're gonna do that. I'm just gonna scratch this off first because I'm stupid and I'm just kind of acting as if we already have tested it. The correct procedure here is to first test the component, then do things to mount it back. Like so. Q-tip. Where is my booze? Where's my booze? Nice and shiny. Let's test that component. See what it measures. I'm going to use the fancy meter for that, since I think this might be a capacitor. It is measuring less than 10 nanofarads. That seems odd. It is in parallel with... Stop running away. It is in parallel with this other capacitor, so I'm going to wait here for measure across here. We're going to get our... Yeah, that's our 0.14 microfarad we saw before, but this thing seems to be kind of nothing, or it's just a ridiculously small value. Let's do it with the multimeter. It's got a slightly lower range. It's measuring 0.4 nano. Or is it? Let's... 0.5 nano. That's a very odd size capacitor. But since it is in parallel with another capacitor, I would wager it is supposed to be a capacitor. But what am I doing? I am cleaning my tweezers and getting this thing installed. Regardless of what this thing actually is, I don't think it's going to be the cause of our failure, since it's obviously an afterthought of some kind. I don't think we need any extra flux for this. I'm going to eat those words, but we'll give it a go. Holding in place with us all the hashtag skills. Now this is going to be very interesting because we have a bunch of crap in the way of our pad, and that's not going to work. The problem with microscopes is they are very much in the way. There we go, that's a bit ugly, but I can see that it's adhered properly to the scratched off copper. Kimmy's Custom Garage says hello. Hello, Kimmy's Custom Garage. So I want to see if these MILF type packages have soldering faults. That is common. But these guys do look fine. Very fine. More MILFs. Lots of MILFs in here. Oh, hello. The solder joint on that cap is actually beginning to crack. You can see the crack right there. That does not look good. That does not look good. That could actually be part of a problem. We have not looked at the bottom side of this board yet. I am just basically denying, very strongly denying that any of the ICs are broken, because I don't want the ICs to be broken. But at some point I'm going to have to face my like confirmation bias and just try and pay this thing up and measure it, reference it with the datasheet and see if we can get anywhere. If the ICs are broken, it's possibly a bad day, but I might have some of them. I might. We do have a row of small caps here, 116 I would wager. Yeah, 116s, which we definitely could measure. This whole thing is not all that high tech now that I'm starting to get a bit of a grasp over it. Someone says checked if a switch isn't faulty. Fair point, we could actually do that. That is a very good suggestion. These are not known for their reliability. However, while turning this on and off, it does change the state of the LED very like properly. It doesn't show any signs of being bad, but we'll measure it just to be on the safe side. Thank you for reminding me to do that. .24 ohms in that position. 0.18. And if we do this, is it gonna change at all? I need to get this desk attached to the wall. .1 ohms, so that did actually make a difference, but this switch I don't think is actually breaking the main circuit, or is it? No, I don't think it is. I think it's just telling the power supply to turn on. It's like a logic output. So I don't think that's actually an issue, even if it is a bit dodgy. But yes, we will give it some booze. Just sliding some booze down the shaft. Over puns. Oh wow, I'm just clicking this thing right into the microphone, aren't I? Let's measure that again. So we had 0.1 ohms before, now we have 0.27, so that did improve slightly. And in the other direction, 0.35 still. But that's actually the on position. The on position has a higher resistance than the off position, which is unusual. Or maybe the leads are just kind of corroded and I'm not measuring it right. Let's just use a lot of force on the pins to force a good connection with this guy. And yes, that seems better. 70 milliohms, which is pretty much what we have in these probes. This switch is probably fine. Let's go to the other side, have a look at the solder joints. Smoke flux every day. God, this is horrifying. Oh, the PCB's all bent around the screw. That's worth noting. This thing's completely impossible to get mounted flat, so microscoping this is going to be a bother. Let's just look at everything. I think that's just flux residue, but it looks slightly suspicious. So I am going to reflow that device. It's a big device, a TO220, mounted on a heatsink. And heavy devices, heavy and hot devices, they tend to fail. They tend to cause their solder joints to go bad anyway. Come on. That seems fine though. You can usually kind of see in the way the solder melts if a solder joint has been failing. Those guys did not show any signs. This guy does not either. Right, well, giving a bit of extra solder. There we go, big blob. Big blob. So, and people are referencing Lewis Rossman in chat, as always. You cannot have an electronics live stream without Lewis Rossman in it. Hey, by the way, let me show you guys something. Let me show you guys something. Something magical. We actually have the blessing of Saint Rossman right there on the wall. So the Rossman is with us. The Ross is with us. This is the pouch, which I'm just going to reflow it for the sake of it. It did not seem to have any issues, but it doesn't hurt. What is this? What is that? It's a big ass choke. I don't like big ass chokes hanging loosely in two solder joints, so these are getting reflowed. Oh Christ, I want to suck the old solder 8 actually. Someone says I look younger than the last time and is asking what my secret is. My secret is strategically being lazy and not shaving so that I look horrible sometimes. That way I can surprise people by not looking completely horrible other times. Oh, those were actually not a big choke, those were a couple of wires which are now pretty much falling into the board. Whoops. Whoops. There we go, they're back. The choke is actually these joints over there. Oh, that's the life, that's in the way. This is the choke, that's the one I want to suck out and reapply. Because the choke is not very well attached to the board, so these joints are going to have seen a fair amount of mechanical stress. There we go, nice and clean, nice and clean. What do we have here on the big connectory type thing? It's hand soldered, looking pretty okay. So, lots of the pins on the connectory type thing are just in parallel, which is very thankful. We have a shit ton of ground, a shit ton of something else, and then like 4 pins that are completely unknown. There's a row of capacitors right beside it. I want to take a look at those. Someone says our inappropriate jokes are flying way too often. I disagree. I think we don't have enough inappropriate jokes. It's not like the children of the world don't come across inappropriate jokes anyway. That looks dodgy. I think we might actually be better off just keeping the microscope camera there forever, since that makes it less eye cancerous when the auto exposure gets a seizure. It's not like it has enough pixels to justify being on a big screen. That looks fine. That's wiring. It looks fine. Someone asks, what do you mean when the auto exposure gets a seizure? When the auto exposure of a microscope does like this thing, where it goes from completely white to completely black like that, just because something changes slightly in the picture. Someone else is asking what the temperature right now is. It's about 22 C outside, maybe 27 in here. It's lovely. Absolutely lovely. That is very, very hand soldered. It's also a heavy TO220, so I want to redo that. Just because it's a big, heavy, freestanding TO220. If we have a look, you can see it has no heatsink, no support, so those solder joints are going to see a lot of mechanical loading. So I'm just going to desolder all the pins except for one and put new solder. Now, some of you may be noting that I'm not really troubleshooting too much and going at this very mechanically. That's because this is an expensive industrial machine that should not be serviced ever. So I want to make sure we really go through it now that we have it apart, so that we can return it to service in as good condition as possible. Oh yeah. Oh yeah. That's some friction. Cleaning out the old solder sucker. And emptying out the big solder cartridge because it's full of garbage. And throwing it away. Ouch, ouch, ouch. Hot, 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 hot. Fuck. Here you can see what happens to these solder cartridges. They get just a big pile of solder inside. And then they stop working because they're full of solder. And now we have little solder balls all over the floor, which is going to completely ruin my floor. Oh well. This floor is new. I don't want to be running solder balls over with my chair, pushing them in, destroying everything. Okay, that's clean enough. Wow, I'm ruining everything today, aren't I? Oh, this filter needs to be replaced soon enough. But not right now. Someone is asking, what are the symptoms? This is a power supply, which, according to the technician who removed it from service, kind of doesn't put out. Like they'll power it on, it'll power the device, it's powering on just fine, but as soon as the process actually starts, it conks out and doesn't provide enough current to keep everything going. The system resets and the wind turbine does not work. Let's desolder one of these capacitors. Oh no, let's actually solder this IC back which I was across. We have a shit ton of soldered crap there for my demonstration, so we need to get rid of that first. Solder. Solder dust is horrible stuff. Right, let's get back to soldering. No need for a microscope on this one. The last one I'll just do like so. So if that IC was falling off, it is no longer. Someone says, couldn't it be something on the bus that's drawing too much current? Yes, it could be, but I have not been out to the station to troubleshoot this. They just gave me this box and said, this thing's broken, fix it, and I'm gonna fix it until there's nothing left to fix. There's probably some kind of loading test in the near future. But right now I want to check specifically a Philips branded capacitor that's right there. The techs working on these windmills tend to be pretty good at diagnosing this stuff, so I have some confidence. This is a 50 volt 47 microfarad capacitor. So let's see what it actually is. 48 microfarads, that's absolutely fine. But yeah, I think we're going to replace this guy anyway. I don't trust old, cheap, small caps. I love my new component cabinets. Oh, I think I need to make a video about those still. And this thing was sitting which way around? We need to verify with the camera that I'm actually putting that back in the right orientation. And indeed I am. So that's a new Nichicon cap going in. I wonder where my 3524 ICs are. I know I ordered some a very, very long time ago. A very long time ago. I'm just looking at the connector. That looks very nice and clean. Let's just redo this entire row of mains filtering components, just in case. They are all heavy and big, and it takes very little time to reflow them. That way we're just guarding ourselves against those guys being a problem. There we go. Oh yeah, we saw some possibly bad solder joints on the big blue caps, so let's reflow those guys. I'm not sure we've done that already. I'm just gonna suck the solder off of them just to be extra sure, because we did see some initial cracking on the top side, and that makes the solder oxidize, and that's a bad time. Okay, I think we have given ourselves a reasonable shot at this thing actually working. We have not found any obvious issues on it, which is very, very discouraging. But I think we could really just hook this thing up and see what kind of output we get. It's a bit annoying since we have to feed it to 30 volts. I don't have an isolation transformer. Hey, this is a power resistor. .12 ohms. Let's just check to make sure that's actually okay. That could be a possible culprit. This is rated 0.12 ohms with 10% tolerance. It's measuring 0.15. Is that within spec? And 0.12 times 1.1. That is out of spec. That is out of spec. Let's desolder that and absolutely check to make sure. This is probably a current sense resistor, and if that's out of spec, then it's not going to provide enough current. Someone asked if I zeroed the leads. Yes, I have. I have about 3 milliohms error on those. Yep. 0.12 ohms, 10%, 3 watts. Let's see what it actually measures out of circuit. So my lead resistance is irregular. Let's make sure we actually have that completely right. We're about 4 milliohms out. This measures 148 milliohms, which is, it's not off by a huge amount, but it is off by a fair few percent. How do you calculate that? It's 23% too much. I don't think that would be enough to cause issues. But it is out of spec. And if this thing is 10% higher than it's allowed to be, that's going to give us a 10% lower current limit. I don't like this. I do not like this. I don't think I have any suitable replacement for it. Do I? I have 0.1 ohm resistors. What do they measure? They should be reasonably high class. This guy is actually within spec for that one. If we include our lead resistance, this guy is just over 110, so this 0.1 is within spec for our 0.12, because I'm really gonna, yeah, we will have a pretty steady, like 4 milliohms lead resistance here. This measures 120, so we're gonna see an actual real resistance of 114, 115, something like that. So I think we'll actually replace this with this 0.1 ohm. We are going to be closer to spec anyway. And it's going to fit absolutely fine in there. Are these leads long enough? This is going to be horrifying. I have to really bend it. Really bend it flat. The leads, it's just barely long enough to reach. Just barely. But I think that's gonna work. I think that's gonna work just fine. Someone says, can you do a 4-wire measurement? And no, I don't have a device to do that. Wait, what did I just click? Stupid mouse. Stupid mouse, go away. I don't like you. My 2-wire meter is pretty decent though. It uses a rather big current for measuring. So as long as the serial leads right, it's very good. Ah shit, this isn't gonna fit at all actually. Because it goes underneath this board, so nope. Damn it. We need to have this lying down, which wouldn't have been a problem if I hadn't just cut the lead on it. Shit, maybe I can find another one that's within spec. Here's another one just like it. Let's hope this guy's going to measure about 120 as well. So I'm going to verify that my leads are zeroed. We are 4 milliohms out. Let's just stab this guy. This one is actually out of spec for the application. That's a shame. So we can manage to get this guy in there if we just extend this leg slightly with a reasonably fat wire. Someone's asking, where are you? You're not in the basement. Indeed, I'm not. I've moved upstairs. That's why I haven't been putting out much content lately. I've been rather busy with that. So let's just cobble together a replacement resistor out of this. So we can use our folded over leg to make the right length. It's going to be something like that. I'm just going to fold the leg out at the right spot. Like so. And we will take a piece of relatively fat wire, bend it up, and crimp it around there, solder it. Like so. Someone says, use the wire you just cut off. No, I want something fat because we have relatively big currents moving through this. And I want to be pretty tight on the spec. And I need this to be very mechanically stable. So a fat wire is much more suitable for the application. Cut this at a slight angle so that it's easier to get through the hole. And let's verify this is going to fit. It's not. Someone in chat is asking if I've ever done anything with Peltier modules. I've played around with them, but they kind of suck for like everything. Just use a compressor if you need that. If you need to pump heat, there you go, that's going to fit just fine. So we will now take some glue, soft rubbery glue. My God, this is tight. Like so. People in chat are talking about Aussie 50 again. Yeah, may he rest in peace. If you're not in the know, he apparently committed suicide just a few days ago. Which is very, very sad. Big Clive has a video on it, which is worth watching. Yeah, also 50 was an inspiration. Big part of the reason I started doing what I'm doing right now. So it's very heartbreaking to see him go. We need to solder this in place now. It's not really wanting to play nice. So we just get a gob of solder there just to keep it in place. Oh, Sudos, you knew him. You knew also 50 personally. My condolences. There we go. So that's our resistor in place. So that's one possible issue rectified. I'm not going to really address anything more about the OSI 50 thing because I'm very bad at talking about such things. So please don't take my silence on the matter for disrespect. So we have an SMP for a PO6 valve. I think that's going to be a diode. Let's verify. SMP 40 PO6. Oh, P channel. Oh, a P channel FET. Yuck. Yuck. Why did they have to use a P channel FET? I don't want to deal with that. What am I doing? What's on the other side of that? We have a B1645, which I do think is a diode. Switch mode power rectifier, probably from the Stone Age. Single diode. $16 amps. Nothing particularly interesting. Pretty high voltage drop. Let's just measure the diode to get an idea what's going on. spaghetti. I would wager this diode is fine. .13 volts one way. And a rising voltage the other way, kind of. That is a bit weird. We have 0.6 volts one way and 0.1 volt the other way. That is an odd measurement. Let's see, we have the anode is pin 1. Pin 1 is towards me, so this is going to be measuring the diode part, and that's measuring 0.5, which is within spec, but if we measure the other way, we'll get 0.1. Am I really doing this right? Am I really doing this right? Pin 3 is the anode. No, I'm not doing that right. That's measuring pretty fine. It's odd that the diode would be measuring 0.6 volts in the other direction, but I suppose there's probably a resistor loading it down, since these switch mode diodes essentially are in parallel with the load. So if we measure resistance across it as well, we're probably going to get a sensible value. Yeah, that's exactly 1k across there, so I think that's just a loading resistor. I think it's time to fire this thing up. I want to see what happens when we do, which means we're gonna have to install some tape on it to cover up this horrible 230 volt stuff, which is also down on the board. Blech. Nasty design. There we go. We also have some 230 in there, which is not going to be very productive. This has such an annoying layout. That ought to work. Let's see what we can get out of this thing. If we bring the voltmeter in. We are not shorting everything to everything else, I don't think. So let's see what we get out of this thing. Meter in view. Power. So it's drawing 3 watts. I think it's in the on position. The 5 volt LED is lit. Let's see if we have any output anywhere. Well, there's 5 volts coming out. Now, what on earth are all of these other things? What's the red and black there? That's 5 volts. I don't have a pin out for this thing, which is a bit of an issue. So there's 14 volts. Well, 15. 19. 14 volts. 14 volts. 19 volts. 19 volts. Nothing. It's not using a huge amount of power, so it's not on fire. That's a good thing. Wait, what was that? Positive 14. It's all positive 14 volts. What's the voltage across our decoupling caps? 21 volts. Is that just going to be primary side voltage for the switching regulator? Let's measure the main rectifying caps. 23 volts, so yeah, that's just a small drop going into this small board. There is a small so the black and red wires are some kind of feedback input because they're going through a resistor into an optocoupler. Is that on? The optocoupler is enabled. There's a 1 volt across the LED side, so that means that it should not have any voltage across it on the transistor side, so we need to get rid of this hot glue and verify that the optocoupler is actually working. There's a nut in the hot glue, which I have thrown away. I need to keep track of that if we ever want to get this thing back together. Right, let's turn it back on and see if the optocoupler is doing its thing. So we'll verify that we still have voltage on the primary side of it. Yes, we do, 1 volt. So we should have pretty much nothing here. 0.17. If we measure as a resistor there, that should probably have a slightly higher voltage. No. Let's see, the opto is going through this small resistor here, which is probably basically invisible to you guys. A free resistor into a pin on the SG3524. So I would wager that is just a feedback circuit for one regulator. And is this? Yeah, these are the 5 volt 8-bit pins here. So I really think this board is going to be working because it is regulating the 5 volt just fine. I have no idea what the actual 8-bit current capability of this thing would be. It's not labeled anywhere as far as I can tell. Does the transformer have a label? The transformer is labeled 2.6 amps on a 14.5 volt winding, which I would wager is the main power winding. So that's actually a fairly beefy transformer. But this is tricky because because we have this big row of capacitors down here which are providing a few various output rails for everything, but since we have now tested the voltage across these caps, which seem to be the only, oh no, they are not, damn it, they are not the only input caps actually. Oh, this is super annoying. We have similarly 2 output windings of a transformer, one going to a 5-volt board here and one going to a big board with the big caps there. So we need to power this device with 2 separate power supplies. That's 21 volts and that's 23. Yeah, these are probably 2 completely separate power supplies actually. They must be. Yeah, these are 2 transformer isolated individual power supplies. So I'm going to bet if we'll measure between the decoupling caps on both sides, we get nothing here. 2 power supplies, one of which is like 5 power supplies. So many power supplies. But we can power one of them at a time using the lamp power supply. If we feed 23 volts in here, it's safer to flip everything over and measure on the output caps we have underneath here to see what the voltages are. This thing is getting a bit warm. Everything's getting slightly warm. Nothing catastrophic though. Someone's asking, could you look at your email when you have time, because the YouTuber I'm looking for is mentioned overpaying a couple of your mails. I'm not sure what mail you're talking about. Someone else is asking, FF, where are you? At home? Yes, I am at home. Pseudos says that I'm in my basement. I am not in the basement. We are no longer in the basement. Someone else says they're heading to Finland next week and I'll be touring my motorbike. Would like to invite you for a beer or 2. Okay, send me an email and perhaps we can do that. Oh, someone gave me $2. Thank you. Raseberry says, hey. Hello. Kimmy Custom, if you're looking for emails you have sent, why can't you just look in your own email box? Anyway, let's get back to the task at hand. So we want about 22 volts-ish. 2 amps, that's fine. So what I want to do is measure the voltage across the small output caps in here, just to see what they are. Let's actually clean these solder joints up with some booze beforehand, just so that it's easier to probe without causing a huge mess. There we go, nice and clean. Okay, let's make sure we have a correct polarity. Yes, we do. Time to get probing. Output on. So the regulator is drawing 40 milliamps sitting idle. Let's see what we have. So this is capacitor number 1. It's got 19 volts. Now that's a 47 microfarad 50 volt cap, so that's fine. The next one, 5 volts. The next one, 5 volts. The next one, is it going to be 5 volts? 5 volts. Next one, 5 volts. Okay, so we seem to have a bunch of, are these independently regulated 5 volts? 8 bits, perhaps? We have all the caps share a negative because we're all going to a big ground plane here, and we have 2 of them sharing one output, one of them going off to somewhere. I really can't tell. And another one also going off to somewhere. Probably just on the top layer. I think they might actually all be in parallel, just to rate it out weirdly. Let's beef that out and see if that's the case. No, they are not all in parallel. Ah, this thing is a bit of a mess. These are in parallel. These are in parallel. This guy is not. This is very odd. I'm not finding any obvious faults with this device at all. Someone says that projection TV inverter I helped you get working still functional or gave up on it. Projection TV inverter. Have I worked on a projection TV inverter? I'm afraid I don't remember. Sorry. Someone says that 5-pin TO92 by the toroid is a switching regulator. Yeah, it's a LM2941T. I think that's of these fixed voltage, super integrated things. Someone says I worked on an inverter board that powers an arc bulb ages ago. I very well might have, but I don't remember. I work on so many things. What are we to do with this poor thing? Let's just check what the LM2941T is. Someone says it's an LDO, that seems more correct. One amp low dropout adjustable regulators, so that means we can easily probe its output to see what it's going to be. And the output pin is the pin closest to me. That pin right there. And the input pin is the one next to it, and the next one is ground, so that's very easy to probe. So we have ground in the middle tab and out in the rightmost one, so I'm gonna bet that's just gonna be 5 volts across there. It's 19 volts. Oops, I shorted out. 19 volts, eh? That seems a bit high. That seems a bit high. Is this poor thing shorted? What's our input voltage? That pin is a bit more annoying to access, but I think we will. 21 volts, so we have a very low input to output voltage differential on this thing. Perhaps that's the issue. This guy is short, let's see. We have 2.1 volts input to output on this. But I think the input is going to be referenced to this. Yes. So if this thing is working, if it's supposed to put out 19 volts, if we raise the supply voltage a bit, the 8-bit voltage should not track. What did I just drop? I just dropped something. A piece of copper wire. So let's see what happens. We can just clamp onto the regulator and measure it while we adjust the voltage. So we have a ground of a tab, output there. So let's adjust the output voltage, and it is actually keeping stable. So I think this might actually be working. Yeah, we're up to almost 24 volts on the input, and that's keeping absolutely stable. And if we just drop it down, there we go, it has about 0.2 volts of drop across it, but it does cap out at 19.78. Could be some kind of constant current thingamajig. But it does regulate, it caps the voltage. I strongly doubt that the device is going to be an issue. So we have output voltages on all the places where we want to have output voltages. I am starting to doubt that this device is actually failed. I am starting to believe that the actual issue might be that it's being overloaded. Someone says, what's the voltage divider for the adjust pin? That's an excellent thing to test. We will take a look at it. We will look at what the voltage divider is, because it's done with labeled SMD resistors. So we can calculate what the output voltage is supposed to be. Thank you. Thank you for that excellent idea, Edward Hartman. That is an excellent idea. So let's see what our pin out is supposed to be. And what our example schematic is going to be. So there can be one resistor from out to adjust, and then another resistor from adjust to ground. So it's going to be one pin from. Let's just get in there. Where's my tweezers? I think for this, it's worth bringing the microscope full screen in all its VGA resolution glory. So we have 8-bit is over there, and that seems to be tracking on the other side of the board. And adjust is which pin? Adjust is for one all the way over on the other side of the IC. which is there. Is this actually going to that giant pad? It's not going to the giant pad. Then it must be going with this tiny trace to this resistor. Let us verify. Yes, we can see the trace down there. So it's going to a 1K resistor, which is then going to either a via to the other side of the board or another tiny trace. I don't think it's going through the board. There are no vias around that, so it has to be going to the other tiny trace. Let us verify. So we will measure from the adjust pin of a regulator to there. That's good. We will measure to the other side of the resistor. That's a good resistor, it measures 1K. This resistor is probably going to go there. It does, but it also probably goes there. Oh, that's weird. There's a lot of magic going on here. So these seem to... The traces going out each side of this resistor are different. This trace is going there, and this trace is going there. So the adjust pin is also connected straight to this, which goes to what I would wager is the output. So this goes probably to the output. Yes. So there's some magic going on, because these are our two datasheet referenced divider resistors. We have one labeled 1542. $15.4K and 1K. So that is going 15.4K and 1K. What's that going to give us? What's the formula? Please don't be something retardedly. Fuck, let's just Google LM2941 calculator. Has anyone made? Are we just going to have like... Yeah, everyone's just doing the LM317, so we have to do the math ourselves. So what's the formula? What is the formula for calculating the 8-bit voltage? Oh, this seems super annoying. Okay, so R1 is supposed to be 1K always, and that is probably what we're seeing. Actually, I don't think a divider resistor is going straight to ground. Oh, it is through a 56k resistor, a 56 ohm resistor. Yes, so we have basically 1k. So to solve for R2, it's VO R1 times VO over Vref minus 1. But how do I calculate VO from... I hate maths. Okay, here's a formula. V8 equals Vref times R1 plus R2 divided by R1. Okay, let's just calculate that. I am horrible at calculations. So Vref is 1.275 times R1 is 1056 ohms plus 15,400 ohms divided by 1056. 19.87 volts is our output voltage. Jesus, my chair's falling apart. So this thing is supposed to put out 19 point something volts. It's working fine. This is not a problem. This regulator is doing what it's supposed to do. And someone in chat solved that long before I did. Someone says, boy, your keyboard is kind of loud. It's a Model M2. It's a Model M. Of course it's loud. As long as this thing is capable of putting a small amount of current, it's going to be fine. And we can actually test that with a resistor, more or less. I mean, if we just hook our the highest load I have is 16 ohms. I don't want to bring out the constant current load. That's such a bother. And the worst part is we don't know the output capability, how much current this thing is supposed to put out on each rail. So we can't easily test it. But I think I'm actually going to have to get out Big Bertha and do some constant current load testing on this thing to like a couple hundred milliamps, something like that, see that all the rails remain within regulation. So I'm going to be back in a moment. I need to get out the constant current load, so that's going to take a few minutes, and I'm going to pause the stream while I'm doing that. So you guys go grab a cup of coffee. I'll be back in a little bit. Hello, we have returned, and the Big Bertha has hidden herself underneath the bench. And we have a couple of leads coming up which are capable of pulling a bit of current. So I have this set up to draw 100 milliamps. And we're just going to go through and test all of the outputs on this thing. So we have, I believe, one 19 volts input output, which is not going to be very high current, and a few 5 volt outputs, which are probably reasonably high current here, as well as a 5 volt output here, which is also going to be reasonably high current. So let's just power this thing on and find our outputs. So let us power this on. It's not going to go on fire. Nope. It is on. So let's start with the 19 volts perhaps. Oh, it's impossible to see what's what on this. But the 19 volts should be coming over somewhere in this end of the connector. We can just measure to the heatsink fan actually. Well, the tab on the regulator, since that is output ground for the 19 volts. Five volts. Come on, I want my 19 volts. How annoying. It really should be coming over in one of these leads. Yes, that is our 19 volts right in the lead by the end there. So I would really expect to see it in one of the connectors here right by the end. Oh, there we go. I was just not pressing the connector down hard enough. So okay, we have our 19 volt, come on, in the top row, second towards the edge. Now we need to find a ground for that, because I want to measure out the connector, I don't want to measure. I don't want to measure from the regulated tab. Finding ground is going to be super duper annoying. We have a bunch of 5 volts rails which share grounds with the 19 volt rail. So I'm finding lots of 15 volts. And then we have the 5 volt rails which are completely separate from all of them. Oh bloody hell, how difficult can it be to find a ground for this thing? I think all the grounds might actually be way over in the middle of a connector, even for the 19 volt rail. somewhere around here. Bloody hell, give me a ground. We have something that's very weird, that's just kind of dropping down when I probe it. No idea what that is. Someone says check the transformer and MOSFET traces on the scope. We may move to something like that if it does not put out voltage properly. But I think it's actually going to be working fine. I don't think this thing is actually broken. There we go, finally a ground. That took a while. Let's just mark that out. You are ground. Jeez. Let's also mark over 19, which is pin number 2. So if we shove our probes in there, come on. Maybe I'm just really bad at measuring this. There we go. 19 volts. So now we will install our official copper wire connectors. These should provide much better coupling. There we go, beautiful. So let's see if we can get 100 milliamps out of this. Again, we don't know what the actual rating of this power supply is, but 100 milliamps is a good start. We will need a couple of probes of a meter stuck to the 8-bit as well. People in chat are talking about OSI 50. I mean, you're free to talk about that. It's a very current issue. I'm just personally not going to really acknowledge it because I'm so bad at talking about things like that. And I'm sure many people who are watching this are not here to hear about that. If you want to find out about OSI 50 stuff, read the chat. I'm sure you can find out everything you need to know. Anyway, I am now going to turn on the load, and we should see a slight drop in this, but not a huge one. And indeed, that's what happens. We were drawing 100 milliamps. We can try just kind of overloading this a bit. I'm going to set it to 200 milliamps. And that looks fine. I would not expect more than about 300 milliamps out of this, so let's see what happens. And it's still fine. Let's just keep going a bit more. It's just an LM2941, so it's not going to be super sensitive as part of it. So 400 milliamps go, and it's working just fine. Hmm. 500 milliamps maybe? That's a lot of current. I really don't think this regulator is a problem. So 500 milliamps go. Yeah. The 19 volt is not our problem. That's going to be fine. absolutely fine. Although we could verify that it actually works on AC power as well, since I was now pairing it from the lab power supply rather than the actual AC mains. So a big part of the circuit was not in service. So we are now 230 volts live. This is going to be dangerous. Let's see. We're not shorting everything 8. We are not. Power on. We have 8-put. Let's load it at 500 mil. And it's absolutely fine. Yeah, I don't think this is an issue at all. So let's move back to the lab power supply and test the 5-volt 8-put. So we have 2 separate 5-volt 8-put rails at least. Oh, I forgot to turn the 8-put off. Sparky, sparky. Right, so let's find a 5-volt 8-put. Probably easier to probe with these copper pieces than... Let's just mark out all the 5-volt ones. So we have one there, one there, probably one there, and one there, lots of 5 volts, and one there, nothing there, nothing there. Then we're probably going to have a bunch of grounds moving forward from the other ground we found. Here. We need to swap probes. So now we're going to be searching for grounds by having a constant at positive 5 volts. So every time we see a voltage on the meter, that's a ground. So that's obviously a ground. That's not a ground. That's a ground. So I have 2 grounds. Not a ground, not a ground, not a ground. That's a ground. There's something weird. More weirdness. Probably the other regulator board. Yeah, I think we're done. So we just have 3 grounds for all those 5-volt pins. Weird. Very, very weird. We don't have like grounds on the other side. No. How odd. Oh, there's another ground. Another ground. And another ground. We would expect at least as many ground pins as we have 5-volt pins. We have 5 5-volt pins, and now we actually have 5 grounds. So if that makes sense, I think we've found most of it. Sudos is saying something about splicing and editing streams. Sorry, I don't edit streams, so that's too much of a bother. I don't even record them locally. Anyway, let's start measuring 5 volts. So, there are probe points. I think this is all one big 5 volt rail there. So I don't think we actually need to measure every single pin of those. I'll verify later that they're actually connected together. No, I can see a big trace there, so they are all one big rail. I have no idea what the output capability of this rail is going to be, so let's start at 100 milliamps again. So that's the load hooked up. And again, as I start the load, we should see a small drop there, but not a huge one. So, 100 milliamps. And it actually goes up because it's compensating. It's got a pretty tight feedback loop, I do think. So 100 milliamps was fine. Let's just jump straight to 300 milliamps. Now that's fine. 500 milliamps. That's fine. This can probably do an amp. So we are going to try drawing 1 amp. And it's fine. I'm not sure how much more than 1 amp I dare draw. This inductor is pretty big, it can probably do like 2 amps at most. Let's try 2 amps and call that good. And it's dropping a bit, so I think that's pretty much as far as it's going to go. That seems absolutely fine. That seems absolutely fine, so we just have one more regulated test now, because I'm going to verify now that all of the 5 volt pins here are connected up in parallel. So we'll do diode tests for quickies. Yep. That one's actually kind of not the same. A slight voltage drop between those, huh? And that one's also not the same. So I think we do need to test that pin there as well. Because it seems to be different. It is indeed different. We have a small resistance between those two, or a diode drop. 330 ohms. Well, let's just load it down and see what happens. Let's just load it down and see what happens. Now we're going to start from 100 milliamps again. If it's a 330 ohm resistor in series with that output, it's not going to be able to supply all that much current. $100 milliamps. Yeah, that just drops to 0 because there's a 330 ohm resistor in series. Is that supposed to be there? Is it not? Let's mark this one out a bit fatter, so we need to double check it once we've checked the other 5 volt regulator, because this is the only weirdness I've seen thus far. That would really perhaps be a problem if there's some jumper link or something that's failed. So the final power supply we're going to be testing is the one that's on this separate board, and that one's got 2 fat wires going there, which are obviously its output, and those go through the board. So we're going to have to power this on from the mains actually, because it's got a completely separate power supply. And let's see if we can find its grounds and outputs. So we are plugging in and we are turning on. So we are now powered by live mains voltage, and we should have some output voltages. Let's see what we can find. It should be somewhere around here. There we go, 5 volts, first try. There we go, let's mark those 8 as well. 5. Ground. Someone says remote feedback pin. Yes, we have feedback to this regulator going from over there. Has my camera stopped? No? I think this camera just freaked out for a second. Anyway, let's see what happens when we load this down with a small amount of current. I think there's going to be a reasonably fat output since we have very thick wires going to it. But we'll start at 100 mil. Now that's fine. Let's jump straight up to 500 milliamps. It's fine. 1 amp. Not 10 amps, 1 amp. And it's dropping a bit. Let's do 2 amps, see what it says. And it current limits. Yeah, it just current limits nicely. I can hear it like switching as it's supposed to be. This is behaving very, very well. And indeed, I would imagine the 5 volt pin we saw being a bit weird, perhaps being a remote feedback pin of some sort. I think it's, oh man, this is, the pinhead and this connector is strange. The pins on the connector don't actually go straight through, but inside this plastic they do a little turny and end up somewhere else. So I'm not sure which connectors actually. The one would be a 330 ohm output impedance, but I would wager it's the one that's going to this red lead here, and we are going to test that. Ohms, and put it in the suspicious one, and we will measure from there to there. And it's, no, that's 330 ohms. Well, that's the one. Where does that even go? Where does that even go? Where are you? What are you? So it goes to something on the top layer of the board. And we can't see shit. It probably goes to one of the pins on the ribbon cable there. That seems to make sense, so it's probably easiest to just measure. I want to just see if it's an input. If it's an input, then it's fine. If it's an output, then I want to make sure that the 330 ohm output impedance is correct. Let's be smart and use one of the copper wire pieces to probe this. Put it in BP mode. Does it? No? It's going to a couple of pins over here. It seems. Yes. Now those pins are going. Oh, they could be the feedback pin. No, it's not. It's going to a via and going to I think some of the stuff over here. Yep. Going to a small transistor type thing. It's probably going to the comparators and the power on reset things. I would wager those are. That might be the power on reset output. The transistor is going to this IC, which is a power on reset IC. A 330 ohm output impedance on that is absolutely fine. And we don't know what that pin is supposed to be. I do wonder what these transistors are though. They are very cryptic. They are not labelled like sane SMD transistors. They are labelled that. Are they soldered properly though? Are you soldered properly? To bring the whole microscope down a bit. Yeah, this all looks pretty fine. A bit ugly, but I don't think that's failed. If that's failed, I'll eat my hat, that's okay. I have a solder joint on the power on reset IC. Are you happy? Are you happy, or are you just about to fall off? For those who weren't here when we started the stream, this IC is a power on reset IC. It's So I would wager this thing has the possibility to just keep whatever equipment is connected in reset as long as the 8-bit is not okay. So I wager that the pin we're looking at is the 8-bit for the power on reset IC. We can probably verify that relatively easily. The IC is a 7705AC. I got a data sheet for that somewhere. Power on reset generator. So our pin is connecting to there. This transistor, that's probably ground, I would wager. That's probably ground. We have ground there. It's not ground. Is it VCC? It's VCC. So that transistor basically connects between power and this transistor and which pin? Pin number 2 there. Reset in. Okay, yeah. The pin with the weird 8-bit impedance is input reset. So that's going to be controlling, I'm assuming, what if this IC puts out a reset signal. I'm not sure what the reset signal is for. It runs off through a bunch of stuff going to a few pins over here. That means that this device is able to reset equipment depending on an input here. So if we have malfunctioning equipment somewhere else that's causing that to trigger, it would easily seem as if this device is the culprit. Or that's not the case, because this thing seems so very healthy that I am just starting to doubt more and more that the diagnosis of this box being damaged is incorrect. I am starting to strongly doubt that this box has suffered any failure at all. So I think what we're going to do is just to replace a bunch of caps in this thing just to have it reconditioned while it's here. And then I'm going to get in touch with the guys and let them know what we've found out, because we've load tested this thing. I very, very strongly doubt a power supply that's working this fine, even though we don't know its specific output capability. It's putting out what I would consider to be reasonable for a power supply this size. Even if we're not testing it 100%, it is keeping stable. It's working fine at a reasonable amount of load. And I really don't think any well-behaved load on this thing is going to cause it to malfunction at all. So I'm going to see if I have like just caps for everything. These are 220/25s. I think 220/25s. These are like 47/50s or something. 116. I'm gonna see if I have some caps. We'll replace everything, and then I think we're pretty much done. I think we're in luck. I think we have most of the parts we need. These are 2,200, probably 35. That's huge. Very small capsule. Do we have any good replacements? 2,200. No. These can't possibly be 2,225. If the blue caps are 2,225, then I'm very disappointed. What's that say? Is that actually 25 volts? 2,225. Look at that, 2,225. Those are on a 23 volt power rail. That's not very well done. That's not very well done, but at least we can replace them with other 2,225s. Someone says they want electronic smoke. Any electronic smoke emitted from this box is very, very expensive. Very, very expensive, so we are not going to see any electronic smoke. Like, if this box were to fail right now, the total, like if it were destroyed, I flushed it down the toilet, the total cost would be thousands upon thousands in downtime and replacement costs. I'm not even sure it's possible to source a replacement for this. Someone said they don't know where to source axial caps, neither do I. So we just don't give a fuck. We'll make it fit. Let's start with the easy stuff. All of these guys. 220/25, right? I think these are all 220/25. Let's just get rid of them. They're all in the same direction, negative towards the edge of the board. That's a horrifying sound. Uh, 220/25. 220/25. Where's the other two? Off you come. 220/25. 220/25. Yeah. 220/25. And I have $220/25. Jesus, that zoomed in. There you go. Beautiful new Panasonic FM series capacitors. With the wrong pin spacing, but I don't care. It's going to be fine. fit. There we go, we'll just solder those in place. Autofocus please, good boy. Get some more water on the soldering sponge. I can't believe we've been streaming for this long and nothing's fallen apart yet. We haven't lost audio, we haven't lost video. The streaming PC has not crashed. Nothing's gone on fire. It's a pretty decent day. Beautiful. Right, yeah, moving on. What are you? 116, and those guys are also 116. I think these are just fine, but we will replace them anyway. Meh. Who can be bothered ripping them from the tape? Snippety. Snippety. Doodah. This one I actually want to mark out the negative for because it's a bit cryptic. Negative, negative, negative. That just decreases my brain power. These are all 116, yeah, and you are 116, and we are replacing you with 125 Chemicon KY. Higher voltages equals better capacitor. And these are lying down, probably for a reason, so let's make sure we do it right. Beautiful 90-degree angles, and they will glue down, so we're going to put some fresh glue underneath them as well. Well, this was a challenge. God damn it, I folded the leads the wrong way on one of them. Rip. We will just take a new one. Someone says but that they can't rewind the video, so it is a fail. I will take that fail. That is a fail I can live with. Compared to our usual fails, that is a very minor fail. Okay, beautiful. I've actually got two fancy new HDMI capture cards coming in the mail quite soon, because I am so deathly tired of these horrible shitty Chinese USB ones we're looking at right now. They're actually just USB 2.0 webcams with some retarded amount of horrifyingly bad processing on board. But soon we will be viewing through proper Blackmagic design. What's they called? Decklink mini recorders, Decklink mini recorders, two of them. PCIe based proper brand name capture cards, which are about €170 each, but it is worth it to just not have to deal with a headache that is these horrifying China cards. So that's all the caps on this board. It's nice and done now. So now we just have the small board. It's got a bunch more 116s on it, so I'm going to have to fetch another couple of caps. We have 1, 2, 3, 4 of them, and we already replaced one. And I think we can recycle the one I folded wrong, because it should have enough leads left for that, yeah. This one is going to be fine as long as it doesn't have to be mounted lying down. We just do it like that. Yeah. Shh, shh, don't tell anyone. Don't tell anyone. 1, 2, 3, 4, 5. They all have a negative pointing towards the center of the board, which is also the same as the final cap, which we're not taking off. So that's good, that's easy to remember. Someone asks, where does this power supply come from? It comes from a Vestas branded wind turbine. Probably some like 500-ish kilowatt thing. I'm not sure what it powers, but whatever it powers is important, because that turbine is powered down right now. should be all the caps. One, I think 2, 3 and 4, and it's actually just 4, not 5. That guy actually looks a bit sad. Oh, this guy is sad. This guy is sad. Listen to that capacitor smelling. I can smell the electrolyte. Let's have a look under the microscope. That is not flux. Perhaps. Perhaps. That's really not looking happy. I want to believe that's just flux, but it does not look like flux at all. The goo on the rubber there might be flux, but the stuff around the leg is not flux. An issue. We've found an issue. This just shows the value of just replacing stuff for the sake of replacing it in industrial high reliability gear. All the other ones seem fine. That means we want to clean the board up a bit, since there's been possible corrosion going on. Someone says check resistance. We might actually do that if I find it. Is it this one? No. Let it go. There she is. Let's have a look on the ESR meter. I will have a look on the ESR meter. You guys cannot see it. I got my zeroing. It's going to be completely off, but we'll have a quick look. I think this actually measured fine, but it could have issues when it gets warm. 400 milliohms. I think that's higher than the other ones. Let's just check another random one. Yeah. No. No, they're pretty much the same, all of them. 400, 500 milliohms. But when they leak, they get weird thermal characteristics. So that might be fine at room temp. And our new ones are actually 200 milliohms, so they're considerably better. And since these are the 8-bit of a switching regulator, that does matter a great deal. Where'd my Q-tip go? That's a disgusting used Q-tip, but it's got one good end on it, so we can use it again. Booze. Time for some booze. So much booze. I love alcohol. I am so happy we actually found something that wasn't just perfect, because everything else in this thing has been perfect, with very, very few exceptions. There we go, that's a bunch of our shit flux and capacitor goo out of the way. So let's get our nice new caps in there. These guys are tight and they don't want to stay in place. That's annoying. Someone asks, is there any way we can bribe ESR meter guy to work on it again? I keep trying. But he won't do it. and he's loaded rich, so I can't just say, hey, you can, I'll buy it for a bunch of money if you just finish this. He's gonna work on it when it feels like it. Which sucks. I have 10 boards for a new version sitting around. But they have no software. That light is not on. That's the wrong switch. I think we need auto exposure again. I think the auto exposure is going to be absolutely horrifying. Something like that. Someone says, mail the ESR meter to China, have them reverse engineer it. Well, the new design is actually completely open source. It has nothing weird or proprietary, and in fact the hardware for the current ESR meter is completely open source. But the software is not, and the software, due to some stupid libraries used to make it easy, is not like releasable without paying like tens of thousands of dollars to a software vendor, and that's not happening. I want to clean this board. Someone says, believe it or not, power from a wind turbine is more expensive than power from the grid. Well, this is like a very, very big wind turbine which is powering the grid. Like, this is not a backyard wind turbine, this is one of the big ones you see like in big wind farms. An industrial one. Okay, just the 2 big caps left. Someone asks, are there links to the open source hardware to the ESR meter? And no, it has never been published, since the project's just kind of stalled due to there just being no software for it. So it's just kind of mehed out. And perhaps I can convince the guy to at least release the schematics, but I doubt it. Yo. Ah, this has gone wrong. No, wait, that's not the caps. Those are the caps. Whoops. I guess we're reflowing those joints. I have no idea what I just desoldered. Can we get like backlight compensation on this stupid camera? No, we cannot. So I think these are glued down. We're going to have to use force to get them out. That's not a flathead screwdriver. That's a flathead screwdriver. Those are some amazing sounds. These are the high-end 125C rated caps though, so these are pretty good usually, they don't fail a lot. But yeah, 25 volts, gosh, that's not cool. Not even hot glue, that's silicone. Snip some of that off. Okay, we are not going to be trying to get rid of that silicone, it's stuck on there too well. So now we just need to monger these guys in place, which is not going to be pretty. We are not going to be able to fit them very well at all. We're going to have to take a wire and jumper it over like so. No way around that, but it doesn't matter, it's just 50 Hz rectifiers. Someone asked what my opinion on the future of the energy market is. I am not very well read on the issue. I like nuclear, as long as you don't give it to people who do bad things with it. And wind and like water storage, I guess, are good options. Just try to keep it simple. Use what works. Don't use things which cause global warming, please. Like, that's basically all I care about. Try to not burn coal or gasoline or diesel, things of that nature, because those are not very good. Those are not very good at all. Yeah. Something like that should work. Yeah, that's going to fit just fine. I'm pretty fine with using like oil for mobile applications, since batteries kind of suck. But I don't see why you would use oil that's very easy to move around and put in mobile things and difficult to come by in applications where you could just be using a wind turbine or a solar panel or anything that's stationary and difficult to move. Okay, ready to be soldered. I will probably put this in the board before we solder the top part. I think that's going to be easier. Let's just calibrate the length of this, in quote marks, axial capacitor. Yeah, like so. There we go. Now we can solder the lead extension in place and be all happy. We can even solder that in place. And let's get some glue underneath there before we completely forget and solder it in place in such a way that we cannot glue it. This is like rubber sealant glue, by the way. I don't think it ever goes conductive. It stays soft. It's basically the kind of stuff you find around the capacitors in, well, power supplies. There we go. Let's do the other capacitor before we flip the board over and solder the other end. Where did the original caps go? I'm taking care not to bend rather the gasket of a capacitor, because that can cause reliability issues in the long term, the long term. Because if you kink the leg right around the gasket, the seal can get damaged. And then you have a capacitor that's leaky, and we all know how that goes. It's not an issue in like the short term. It takes quite a few years for issues to arise, but they can arise, and I have seen it happen. Let's calibrate the length of this guy as well. Yeah. Something like so. Oh yeah, let's be smart and put the glue in first this time around. This tube is drying up. Ah! It's actually pretty good to have a half dried up tube, because the glue is very sticky, making it very easy to just let components rest on the glue while it's being worked on. Oh yeah, we should do. We'll do a little tiny bit of extra flux on there, just to make it take a bit better, because the other one was a bit dicky. Beautiful. Okay, flip it around. solder the other end. Like so. Is that joint fine? It's not really. I want to just add a tiny dab as all the... It's actually attached on the top side, so this doesn't really matter. But it looks better. So now we just need to trim the leads and we're going to be pretty okay, I think. Someone just called this an electronics ASMR video. What's ASMR about this? I'm just speaking softly because I've been talking so much that my throat hurts. Let's add a tiny dab of glue on top of these just to make sure they stay in place. Like so. Beautiful. I think we're starting to get done. I want to... Part of me wants to reflow these MILF diodes, because MILF packages love to fall off. It's weird since they are supposedly a high reliability package, but they love to fall off. The devices don't fail, they just fall off. Is it MILF packages? I don't know. I don't care. I just call them MILF packages. I thought it was like military something. But MILF does sound better. I thought it was just like a hilarious coincidence. Come on. Ah, there are so many things in the way. So many things in the way. So if you buy a new old stock MILF package, does that turn it into a GILF package? Hashtag demonetized. Where's my soldering iron? There we go. I really don't care about monetizing the live streams. Like, someone donated $2 already. That's more than I make from the advertising on these in like a year. Oh, this doesn't get done. I don't want to touch this because I know this regulator works. We have load tested it. The only thing that's a bit questionable is the power on reset circuit, but I'm not quite sure what the criteria it's using is. And I would imagine it's probably used to reset the power supply. That's going to, the reset circuit is going to the connector. I just strongly doubt if there's anything wrong with this. Kimmy Customs is gonna go build a Peltier drink chiller. Enjoy yourself, Kimmy. I think we are putting this thing back together. It's annoying. If I had a replacement for the power on reset IC, I would install it. But I have no reason to assume that failed. The symptoms described don't really match up. The power on reset IC could potentially cause issues when it's loaded down. But I'll have to order one anyway. I'm just going to take a high-res picture of that, and if we don't find any other issue, I'm going to have to order basically all the chips for this thing and just swap them out. But since I can't replace it right now anyway, I think it might be a better use of our time to just try this thing. Try putting it back in service. High-res picture achieved. Someone asks, when is the next travel? I have no idea. I don't plan my life ahead. I just do things. Yeah, this thing going back together now. We have found one bad capacitor, but that is also the only issue we have found. That's going to go together just fine. Hot glue, get out of my way. Okay, I guess we're reusing the hot glue since that is... No, we are not reusing the hot glue because we can't do the bloody nuts. Gah. They have used high quality hot glue, I guess I'll give them that. And let's see which of our 1000 screws go where. No, this thing has so many screws. All of them are loose. I think it's these guys that go through the board. These are pussy driver ones. Someone says, why not test it first? We have tested it quite a lot. I've just swapped out a bunch of components very mechanically. I do not think we have induced a failure. You're right though, it's a good idea to give it just a quick test before completely reassembling it. If we still have 8-bit voltages, then we know we haven't broken anything. Let's just do that. Make sure our caps aren't in the wrong way round. Make sure no smoke comes out. No fire, no flames. IEC, please. So this is on 19 volt. Someone says, afternoon, what have I missed? Pretty much everything, I'm afraid. We have more or less concluded that this thing does not seem to have problems. Power going on. Our 19 volt is fine. Five volt number 1 is fine. And 5 volt number 2 is fine. I think this device is fine. And that whatever's causing the issue is very likely to be on the 8-bit side. So we can put this back together. We have done what we can, and a lot we have done. Geez, for how long has this been going on? I don't have my stream timer. 3 hours. Shush. it's going to take like another 5 hours to put this back together, so I am going to fetch a bit of water. The sounds of house walking. Rector Magnificus has to go. Enjoy yourself. Right. Let's see how this thing went back together. It was really annoying to get apart. Really annoying. We don't need a crotch cam. There we go. So these two screws go through the case. There's a bunch of tiny ones which also go through the case. Now there's one fat one, I don't remember what it does. And yeah, those hold the board in place. It might just be one. Oh, this thing is such a bother to put together. Oh no, I see what I've done wrong. I put some screws in here which are not supposed to be there. Because these screws attach through the case, and the screws I did put there are supposed to hold the board down. A very weird construction of this thing. Very, very weird. Someone says, that's so weird, not hearing stairs when FF goes away for a bit. I know, it's amazing. I have a water tap and a toilet on the same floor I work on. Woohoo! Achievement unlocked. Okay, so this is the bad part where we have to like completely monger this thing in place. Full of dust. Oh yeah, this thing slides in there, so we have to slide the whole thing using like 20 hands. And yeah, this guy can't slide because it's got a switch sticking out, so we have to slide the connector like so, and then we have to kind of just bend and rip the wiring so if we can get the switch to go through there. Now the connector just came off. God, this is super annoying. And now this just kind of pushes down like so, and it's held down by 3 screws. That's not gone well. We should actually start out with these guys going from the bottom, because we really need to align these standoffs with the holes on the bottom, else it's just not going to work at all. Station 240 in the chat says, a wild FF has escaped the basement. Indeed. It's a lot nicer to bring customers into a workshop that's not like seeming to lead into an underground sex dungeon. There we go. God, this case is so bendy. And we have a ground log that's supposed to be soldered there. And we will solder it because ground is important. There we go. And now these do a ballet. The tape can come off. And that kind of locks in there, I think. Oh no, we need to hook this in at the slanted side and then just kind of bend everything. There we go. And it's slowly turning into a sleek Robocop-like design. Someone asks, so is it a switch mode power supply at all? Yes, it is a secondary side switch mode power supply. It's got a primary side transformer bringing 230 volts down to about 20 volts DC. Then it's got two switch mode converters running off of that 20 volt rail. Well, two 20 volt rails, since the transformer has two windings which are electrically separated. And it also has one linearly regulated output of 19.7 volts. So yes, it has two switch mode regulators inside and one linear transformer and 50 Hz rectifiers. Relatively common 80s design. These are more resilient usually to bad power grid supplies, since they have a big transformer which is fat and slow connected to a power grid, so any small spikes are usually just going to go away in the transformer rectifier setup, and there's very little risk of damaging any early 80s style primary side switch mode IC, which would be a very delicate sensitive flower. So for the time, these were not that bad. They were not that much less efficient either, since 80s switch mode power supplies were not marvels of efficiency. How do I know it's 80s? Just look at it. That aesthetic though. Trans-Electro. That's a cool logo. Very vintage. Someone says, so because it was built a long time ago, the transformer was more reliable than the mains SMPS circuit. Well, I mean, that is always the case. That's true even today. But yes, that's part of the motivation for making one of these. And it provides better mains isolation. These aluminium profiles are not very good for screwing. All of these screws are shitty. Every single one. They just want to fall off. Nothing we can do about that. I think we're done. It's back together. Oh, it's a beauty. So it's a KTAS STT 3357. Turn power off before module exchanges. The shape of this thing. Looks like a toy car. Someone asks, where was this from? A Vestas big ass wind turbine. So let's see what happens when we turn it on. So now the power's on, and we get a single LED, which I think is good because the error one's not lit. And with that, I think we're done. We have replaced quite a few parts in this thing, actually, despite not finding any really serious issues with it. Two components had failed in such a manner that I would not have been comfortable putting them back into service. Let's see. So one was this current sense resistor. It's 120 milliohms and it measured 150, which is quite a ways out of its 10% spec. Since this is higher value than it's supposed to be, the current limiter is going to be lower, which could cause issues. The other component was one of these 100 microfarad 16 volt caps had leaked, actually. It still measured pretty fine, but when they leak they often go a bit weird and don't work properly. The rest of the components were just swapped out because they're older caps. They all measured fine, but they're 25 years old, so they are way past their sell-by date. Someone says this just cost 750 euros. That is bloody cheap. Is that on eBay? Like, just the day and time of this thing here has cost more than 750 euros already. But yeah, I think we are quite ready to pack up, because this is done and it needs to go home. So I'm going to have to thank everyone for watching, and make sure you enjoy yourself. And now I need to find the mouse going to the streaming PC so I can stop the stream and have some dinner. Goodbye.